Okay, we're back at it, reading the Rust programming language, and today we're going to cover the section of Chapter 5 on methods. Let's jump right in. So methods they're similar to functions, and we declare them with the fun keyword and a name. I'm sorry, but fun is not actually necessarily about having fun, but you could have fun writing a Rust function, and they can have parameters and a return value. And they contain some code that runs when the method is called from somewhere else. Unlike functions, methods are defined within the context of a struct or an enum or a trait object, which we cover in Chapter 6 and Chapter 8 respectively, and their first parameter is always self, which represents the instance of the struct the method is being called on. So a couple of things to unpack there. One of them is, notice that it's not just about struct, but it's also about enums and trait objects, that multiple things in Rust can have methods. And then the second thing, perhaps maybe it should have been the first, is that it doesn't require the kind of typical object-oriented programming that you find in languages like C++ or Python, where you're kind of adding methods that have self, and Rust does call it a method. However, there's no inheritance. So Rust deals with things in a very different way, with especially traits for getting kind of shared functionality among multiple things that follow some kind of, call it an API design or API schema of sorts. However, it doesn't have inheritance. And so some would argue that this isn't properly a method or isn't properly object-oriented programming or whatever you want to, get concerned about there. But anyway, those are two things to keep in mind with methods in Rust when we're putting them on structs or enums or traits. All right, let's get into the next section here. So the method syntax, how do we write it basically? So let's change the area function that has a rectangle instance as a parameter, instead make an area method defined on the rectangle struct as shown in listing 5-13. You may actually recognize some of this code from the last video we did on the previous section, but we're going to do it from scratch just because I want the practice. Let's do it together, shall we? So we've got this derive debug trait, and it can only be applied to struct, so it's complaining at the moment, but we can add our struct. Here's our rectangle, and we can say that our rectangle has a width of U32, and it has a height of type U32, not of 32 exactly. And then we have here's where we're going to add our method inside of what's called an impl block or an implementation block. I'm sure we'll talk about it more, but here's our impl block, our implementation block, and we're going to write one for area. It's going to take in a reference to self, which is kind of analogous, but not really the same as self in like Python or other object-oriented programming languages. It looks and feels similar though. So we'll go self.width multiply by self.height. So that'll return whatever is the area for whatever instance of struct we have. And hence it's a self thing. It's not just an associated function that's attached. It actually knows internally about things that are inside of a rectangle. Okay. Of some given rectangle, not just any rectangle. So now let's go into our main function and let's make it happen, Captain. So we go let rect1, we'll define an instance of our rectangle struct, and we'll say that we have a width of 30, and we'll say there's a height of 50. And a semicolon for our declaration there, and we'll call println macro. I guess it's not really calling in the usual sense because it's not a normal kind of function, but it's a kind of compiler directive. The area of the rectangle is blah, 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 square pixels, and then we can pass into that rect1. So this is going to calculate the area not just of some arbitrary struct or arbitrary data that we passed in that may or may not be related to a rectangle. This is specifically attached to our rectangle in the sense of being a method on an instance of rectangle where it has this area method. Okay, so let's just double check that this works. There we go. If you've seen the previous video, then you've seen this particular statement multiple times over. Let's move on. So to define the function within the context of rectangle, we start with an implementation block for rectangle. Now I have a feeling like they're going to go through what I just yapped on about, but that's okay. So everything within this impl block will be associated with the rectangle type. Absolutely. So every kind of instance of rectangle that we make will have this method on it, but because it takes in self, which I think it's going to talk about in a moment, it will be able to access internal attributes. So then when we move the area function within the impl curly brackets and change the first, and in this case the only parameter to be self, in the signature and everywhere else in the body. In the main function, we called the area function and passed rect1 as an argument. We can instead use method syntax to call the area method on our rectangle instance. So from the last video, that's exactly what we did, is we defined a function that's just a standalone function, and it could take in two arguments representing the length and the width, and just multiply them together for us, the width and the height, sorry. The method syntax goes after an instance. We add a dot following the method, followed by the method name, parentheses, and any arguments. So the method syntax goes after the instance. That's just to say, I think here they're just saying that we've got the instance dot area. That's fine. In the signature for area, we used a reference to self instead of rectangle reference to rectangle. The reference to self is actually short for self reference to capital S self. Within an impl block, the type self is an alias for the type that the impl block is for. So this is a kind of abstraction layer so that you can just refer to self and don't have to be explicit about the underlying types. Within an impl block, the self type is an alias for that type that the impl block is for. Yeah, sorry, we just read that in methods. Methods must have a parameter named self or capital S self for their first parameter. So Rust lets you abbreviate this with only the name self in the first parameter spot. Note that we still need to use the ampersand in front of the self shorthand to indicate that this method borrows the self instance, just as we did in rectangle reference to rectangle. Methods can take ownership of self, borrow self immutably, as we've done here before, or borrow self mutably, just as they can any other parameter. We chose reference to self here for the same reason we used reference to rectangle in the function version. We don't want to take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we called the method on as part of what the method does, we'd use ampersand mute self, or mutable reference to self, as the first parameter. Having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else, and you want to prevent the caller from using the original instance after the transformation. I'm not sure off the top of my head that I have an example of where you would want to allow for that behavior, but it's something we can note as an allowed thing, but maybe not a common thing. If you're thinking about how to implement a problem, you might want to think about whether there are alternatives to just passing self. The main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of self in every method signature, is for organization. We've put all the things we can do with an instance of a type in one impl block, rather than making future users of our code search for capabilities of rectangle in various places in the library we provide. Yes, there is a kind of point. I have to think more about how to integrate this with Rust, but I know that for Python there's a bunch of things where you don't necessarily need like a class. Sometimes it's okay to write a module and use the module itself that contains constants and functions, and I expect this to some extent that's fine for Rust, but it really depends on things like, do you want it to be a singleton? If we're talking about having multiple rectangles, arguably not. Note that we can choose to give a method the same name as one of the struct's fields. For example, we can define a method on a rectangle that is also named width. So here we have impl width. Let's type it out just to see. We can add width, reference to self, bool, and we'll say self dot width is strictly greater than 0. Not sure why we're doing that particular function, but it's a thing that we can do. And then we've got our rectangle down here, and we can say the rectangle has non-zero width. It is blah, 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 period. And then we'll go rectangle width. It's complaining here in the static analysis of the code that height is never used, that area is never used. And for writing certain kinds of like library utilities, it may not be used. It depends. But sometimes this can be a useful indication that something is basically dead code. All right. Okay. So the rectangle has non-zero width. It is true. It's a little bit clunky there. Did I put an extra space? I did. There we go. That looks a little bit more naturally spaced. Here, we're choosing to make the width method return true if the value in the instance's width field is greater than 0, and false if the value is 0. Sure. So we're just saying if width is strictly greater than 0, return true. Otherwise, return false. That's fine. Okay, in main, if the value is 0, we can use a field within a method of the same name for any purpose. Sure. And that's what I guess they're getting at with their point here, is that, which I summarily went on to ignore, but we have an attribute here of width, right? But then it was also fine to have this additional method attached called width as well. It knows the difference between what is one of these directly declared struct attributes versus one of these methods. Great. Now, for any purpose in main, we follow rect1.width with parentheses. Yeah, so we're calling a function, and that's how Rust will know. So Rust knows we mean the method width when we do that. When we don't use parentheses, Rust knows we mean the value width. That's kind of contrasted a little bit to like Python, where, you know, I might define like a class foo, and then I might say, you know, I don't know, what are we talking about? It doesn't even really matter, does it? But we could say rectangle self width, and then like dot 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 for just well, I'm not that lazy. I'm getting pretty lazy though. Okay, so here we've got self.height is equal to height. Okay, so my point here is it's okay in Python to have like width. However, it will, to some extent, it will become a problem of not knowing which one is which, and often that's where people are doing things like including property. So cannot assign it, and I think it's because width has no defined setter. I see. So it's kind of complaining that I've declared this, you know, like property method here, and with that property method, that would have allowed a kind of syntax that says I could have like rectangle width, and that because of that property being added means that the width would refer to this width. It creates a contradiction in what we're trying to define here. So it gets confusing. But with Rust, you don't have that special property decorator, and you probably shouldn't abuse that notation. It's just in Rust you get to say, well, there's a width, either function, method, if you will, or there's the width attribute. I actually think that's pretty good. Often, but not always, when we give a method the same name as a field, we want it to return only the value in the field and do nothing else. Sure. Now, methods like this are called getters, and Rust does not implement them automatically for struct fields, as in some other languages. Getters are useful because you can make the field private, but the method public. and thus enable read-only access to that field as part of the types API. That makes sense. We discuss what public and private are and how to design a field or method as public or private in Chapter 7. So if I remember right, yeah, I mean, Rust has certain rules about how it does that, but Rust does actually distinguish between private and public, whereas Python doesn't officially do it, but there's some conventions there that weakly inform rather than enforce, respecting public API. Okay, so where is the arrow operator? In C and C++, two different operators are used for calling methods. You use the dot if you're calling a method on an object directly, and you use the arrow if you're calling the method on a pointer to the object and need a dereference to dereference the pointer first, blah, blah, blah. In other words, if object is a pointer, object arrow something called is similar to dereference object and then call something on it. Rust doesn't have an equivalent arrow operator. Instead, Rust has a feature called automatic referencing and dereferencing, which is clearly quite nice here. Calling methods is one of the few places in Rust with this behavior. Yeah, I mean, I don't think that by default all over the place you want to be having things automatically referenced and dereferenced, but this is kind of a classic issue with early object notation, dot notation with calling on things that you've defined. It solves a problem of sorts. So here's how it works. When you call a method with object.something called, Rust automatically adds a ampersand or ampersand mute or star so that the object matches the signature of the method. That's pretty smart. In other words, the following are the same. Wonder if that actually errors or what that does. No output. Okay, that's fine. The first one looks much cleaner. It looks moderately cleaner. I mean, it's still quite similar, frankly, but I think what's kind of a win is you don't need to think about what to put in there. This automatic referencing behavior works because methods have a clear receiver, the type of self. Given the receiver and the name of a method, Rust can figure out definitively whether the method is reading reference to self, mutating, that is having a mute self, or consuming reference to mutable reference to self, or consuming self. The fact that Rust makes borrowing explicit for method receivers is a big part of making ownership ergonomic in practice. Nice. I'm a fan. Methods with more parameters. Let's practice using methods by implementing a second method on the rectangle struct. This time, we want an instance of rectangle to take another instance of rectangle and return true. If the second rectangle can fit completely within the self that is the first rectangle. So in other words, is one rectangle inside of another, we'd like to be able to check. Otherwise, it should return false. Sure. That is, once we've defined canHold method, we want to be able to write the program listing shown in 5-14. Okay, so let's okay, so I think we're keeping the rectangle definition, and here inside of the main function, we're just defining more rectangles. There's a rectangle. They've got a width of 10 for this one and a height of 40. Fair enough. And then we will get a third rectangle, which is more of a wide. Okay, great. So now we've got these definitions, declarations of some structs. Let's print line macro, and let's see what they want to do to compare here. Rect1 hold rect2. Rect can hold, and we'll have to implement this. So we're going to get, errors that complain that we don't have this because, well, we don't have this. And then can rect1 hold 3. Make sure those are semicolons. A little bit of formatting. All right. So the expected output would look like the following because of the dimensions of rect2 being smaller than the dimension of rect1, but rect3 is wider than rect1. Yes, but this code doesn't actually work. We're going to get an error. Cannot find the rectangles, which is actually partly because of a bug that I introduced, which is we do need to actually refer to rect1, but we're still going to get an error because it doesn't have this method can hold. There we go. But you know what? We just need to define it. We'll get to that. I see it down here. We'll follow their example when we get to it. So we know that we want to define a method so that within the impl rectangle block, so that it will be within the impl rectangle block, the method name will be canHold. That's what we've declared it to be. And it will be an immutable borrow of another rectangle as a parameter. We can tell that the type of parameter will be looking at the code that calls the method rect1 canHold, passing in a reference to rect2, passes in the reference to rect2, which is an immutable borrow of rect2, an instance of rectangle. Yep, this all just follows from the notation, which is fantastic. This makes sense because we only need to read rect2 rather than write. Sure, we're not modifying it, which would mean we'd need a mutable borrow. And we want main to retain ownership of rect2 so that we can use it again after calling the canHold method. The value of canHold will be a Boolean, and the implementation will check whether the width and height of the self are greater than the width and height of the other rectangle, respectively. Let's add the new canHold method to the impl block from listing 5-13, and let's just jump in and do it. Okay, so actually let's put it up here, and we can probably get rid of the width calculation there. So fun. canHold. I'm gonna pass in a reference to self, and the other is going to be a reference, an immutable reference to rectangle. I'm gonna pass in an immutable reference to a rectangle. We'll take width, and we will check, is it strictly greater than the other width, and self.height, is it strictly greater than the other's height. Now this should work. There we go. We have our little true and false answers, respectively, for our two example triangles. We're in pretty good shape here. Okay. When we run this code with the main function in listing 5-14, we'll get our desired output. Methods can take multiple parameters that we add to the signature after the self parameter. So similar to languages like Python, you should put self first. It's a very self-ish language that way. And those parameters work just like parameters in functions. So now we're going to do something that's similar to methods, but actually not the same, where is it possible to not include self? And the answer is yes. So what if I want to calculate something like, is it square, or return something that is a square based on a size calculation? Let's do it. This is almost like a factory. I'm looking at this going, okay, type self, passing in width and height. Okay, let's get into this. So all functions defined within an impl block are associated functions because they're associated with the type named after the impl. Totally. We can define associated functions that don't have self as their first parameter and thus are not methods because they don't need an instance to the type to work with it. We've already used one function like this, the string from function that's defined on the string type. Associated functions that aren't methods are often used for constructors that will return a new instance of a struct. Makes sense? We might want some convenient way of putting it together. These are often called new, but new isn't a special name in Rust. It isn't built into the language. For example, we could choose to provide an associated function named square that would have one dimension parameter and use that as both width and height, thus making it easier to create a rectangle, square, rectangle, rather than having to specify the same value twice. So let's do it. We'll add to our collection of impls here, square, and we'll pass in size that will be a unsigned 32-bit integer, unsigned, yep, and it's going to return self. What is self? Self is going to be rectangle, right? In this struct, it's not that in general. So what is this going to return? We're going to construct self. We're going to pass in whatever size is and height. And this is in some sense creating a square because we're taking the same dimension and saying that it's both the width and a height, width and the height. And that's what, that's what a square is. So that pretty much covers that. The self keywords in the return type and in the body of the function are aliases for the type that appears after the impl keyword in the case of rectangle. So let's just, we haven't made an example, but we should just be able to go cargo check here and make sure that that compiles and it's thinking that that extra function, associated function, is dead code, but that's okay. We're not going to actually use it anyway. So to call this associated function, we use the : syntax with the struct name, let square rectangle : square is an example. This function is namespaced by the struct, which is nice. The : syntax is used for both associated functions and namespaces created by modules. We'll discuss modules more in Chapter 7. Looking forward to it. That's in packages, crates, and modules. Okay, so now we can get into having multiple impl blocks. Let's do it. So we'll, for whatever reason that we feel like, we'll have another impl rectangle, and we'll say fun can hold other as in an immutable reference to a rectangle. This returns a bool. And we'll return the same calculation of self.width is strictly greater than other.width, and self.height is greater than other.height. And we're going to get a problem here, which is duplicate definitions, which is nice. We're not going to accidentally create duplicates. So if I try to compile, I'll get all these errors complaining that I tried to make 2 copies of something. But if I get rid of it, there we go. No problem. There's no reason to separate these methods into multiple impl blocks here, but this is valid syntax. We'll see a case in which multiple impl blocks are useful, where we discuss generic and typed traits. Looking forward to that quite a bit, actually. Okay, so let's summarize. Structs let you create custom types that are meaningful to your domain. So domain-driven design if you want it. By using structs, you can keep associated pieces of data connected to each other and name each piece to make your code clear. In impl blocks, you can define functions that are associated with your type, and methods are a kind of associated function that let you specify the behavior that instances of your struct have. Both structs aren't but structs are not the only way you can create a custom type. Let's turn to Rust's enum feature to add another tool to your toolbox. Also looking forward to that, but that's the end of this video, just going through methods and, as a bonus, associated functions as a more general class of functions that you can attach to a struct. And with that, I will catch you, see you, high five you in the next video. Take care.